For me, there's no more iconic 1980s 8-bit computing experience than this. Starting up the Commodore 64, the Commodore 1702 video monitor, and the Commodore 1541 single floppy disk. In this video, I'm going to show you this unique 1541 drive. It's not the 1541 that you're used to. This is the 1541 DC, a direct current powered version of the 1541. So what's different about this? Let's take a look. With this 1541, you see the familiar power switch, but instead of the IEC AC input, you've got a 4-pin DIN DC input, like on the Commodore 1541-2. Because there's no AC input, we also don't need a fuse for the AC input. So we put the missing 1541's device number switch in place of the fuse. Other than that, the device is as it was before, but that's the 1541 DC that I'll be showing you today. My inspiration to make a DC version of the Commodore 1541 was that I wanted a new power supply for my Commodore 64, and I was seeing that there were a number of them available online, like for instance this one from Keelog, that not only provide a connector for the Commodore 64, but also could provide one for a floppy disk drive such as the 1541-2 or 1571-2, or I think the 1581 as well. So wouldn't it be neat if I could get one power supply that would power both of them? As you well may know, there are a number of people that have posted great videos and content on the web about how to replace the power supply in your 1541. The old AC power supply that needs to supply both 12 volts DC and 5 volts DC to the 1541 components. Those are great. The idea is to, well, first just update the power supply, so eliminate old components that might fail, but also to make it run cooler, because there are modern power supplies that can provide both the 12 and 5 volts, and they can fit in the space left where the old Commodore power supply was in the 1541 case. So that was the other option, and I thought, well, it would just be nice. What about if I just put the 1541-2 connector, the 4-pin DIN DC connector on the back of it, and then I can solve the power supply problem separately. Just break it out of there. And then there's no high voltages in the 1541. There's no voltage regulators. There's no transformer, so it runs cool as a cucumber, just like it does if you replace it with the modern power supply. But I guess you could say it's going to be even cooler than that because there's no power supply in there at all. So let's go to the bench, and I'll give you a tour of the inside of it to show you what you would need to do to build such a thing. So here we are at my bench with the 1541 that I've already done the changes to convert it to DC power. And what I'm going to do is just give you a little tour of it and show you where it differs, for instance, from existing projects. In the video comments, I'll link 2 important videos. Adrian Black's from Adrian Digital Basement's video about how to replace the power supply with a modern switching power supply, and also one from Dr. 64 who did the same thing just with a different brand of switching power supply. Those 2 videos were invaluable and basically guided me through 80 or 90% of what I've done here. So check those out to see some details that I'm going to gloss over pretty quickly in the tour. So I've removed the screws. I left as many of the screws out of this at this point, just to facilitate making this video, but we'll go back and put the back. So remove this in my guard. So here we have the 1541. This particular one was made in 1984, assembled in Japan. So basically we're going to remove the parts of the AC to DC linear power supply. And that involved these 2 capacitors here. So I snipped those out. There are 2 voltage converters that I've written for 5 and 12 volts here. They look like this. You remove those. That's one of the parts that might cause you a little more trouble than others. It's pretty easy, but you need to desolder them from the underside. And the bridge rectifiers are over here. There's some capacitors here. They're filter caps that Dr. 64 does a good job of explaining what those are. And you can just remove all of those. At first I didn't remove them, and in Adrian's video he doesn't remove the filter caps and he doesn't remove the bridge rectifiers, thinking that once the transformer is gone and he's replaced the other pieces that wouldn't be a problem. But I found it seems to put maybe it seems that it's possible that it interfered. Anyway, it's not needed in the DC version, so I decided to remove it during my troubleshooting. So let's take this board off and see what it looks like inside. Let's unplug these. I've labeled them already with different colors so I know which one goes where. And that will allow us to put this board up here and give you a tour of what's inside. So what have we done here? Well, what we've done is remove the ginormous transformer. This is the thing that makes the 1541 ridiculously heavy. It just has 4 screws in that bottom plate there that you take out. Actually, let's take this chassis out of the bottom of the case so we can get a better look at things. All right, so we removed the transformer from down in the bottom here. We've removed the fuse holder, which is part of the AC componentry that was over here. We've removed the IEC AC mains jack that was in here, and saved the screws from those because that's useful. I didn't need to buy new screws or use any new ones. I was able to use the ones that were reclaimed from taking the other components out to put things back in there. And then one of the things that you'll need is to buy the 4-pin female DIN connector that you're going to use for the DC input, and that's mounted right down here. Now to do that, what I decided to do was take a piece of aluminum flashing. I had pieces of aluminum flashing like this laying around for roofing work on the house, and you can use tin snips to just cut out pieces. So basically what I did is cut out a piece that would cover both the fuse holder hole and the IEC connection there, and then use the drill to drill the position for the 4-pin DIN to mount in that plate. Let me show you what that looks like. So on the back of the device, what we have here is a single pole, single throw hole mount mounted in that piece of aluminum, mounted and then labeled with the device 8 and 9 positions, and then the hole drilled here to put the 4-pin DIN socket in there, and then used reclaimed screws from components like the heatsink that was around the voltage regulators. Reuse those screws to mount that in there, and then these are the 2 screws that were mounting the IEC power socket before. One of the most difficult things for me to find was actually the right switch to go over here. The standard 1541 has this switch. It's an AC single pole, single throw switch, and it nicely mounts in this machined thing right here. I'll show you. I'll show you how I mounts in this hole here. Once we've converted this over to DC power, we've got 2 different voltages to switch, not just one anymore. We have to switch both the 5 volt and the 12 volt. So there's a plus 5 volt pin, a plus 12 volt pin, and a ground. And we can't use the old switch because you can't do something like, say, for instance, just switch the ground instead, because you end up with a floating ground, and even when the device is off, the motor will spin and things like that. It just doesn't work. You need a switch like they have in the 1541-2. In the 1541-2, however, they've mounted, like on a Commodore 64 itself, they've mounted the switch on the PCB itself, where here it's a rocker switch that's mounted in, that's a panel mount. So I scoured the internet to try to find an industrial rocker switch of the quality and type and general appearance that the Commodore one has, that would fit in that opening, and I thought I had found it here. Well, I thought I'd found it. It's the same brand, and it does fit. It ultimately fit in there, but the measurements were metric instead of standard, and it was ever so slightly too wide to fit in there. So let me show you how I managed to fix that. So the last piece of this puzzle was to find a dual pole single throw switch that fit in the position where the original Commodore switch was. So here I've got the 1541 out of its case. Here's where the original on-off single pole single throw switch fit, and it just fits right into this nicely machined piece of equipment. Now this particular switch, or the original, is a Russenberger brand switch, that they were using for the AC power input. Poking around on eBay, I managed to find this one. So this is branded as Light Country double pole single throw, and the measurements were given, I believe, in millimeters, where it seems to be a standard measurement for this one, but it was basically identical when I compared them. Now looking at them though, here's the new switch, so it's not quite as high. That's okay, I can block off a portion of the space there, but it doesn't quite fit in. It needs like a millimeter or two more, and you can see how close they are in size. So almost, but not quite the same width. So as often happens in projects like this, it's going to take a little brute force to get this working. So let's see what we're going to do there. What might we try? All right, well, the first thing I'm going to do is trim down the non-labeled edge a bit here. All right, so let's see if we did anything there yet. Still not quite. It's enough with the knife. I think what I'm going to do is get out my file and see what we can do with maybe something like, see if I can take off some material on the side like this. I'm going to go do that at a place where I can make a bigger mess though. All right, I'm back from the outdoors applying a little elbow grease to this thing. So what I did was found a good way I can hold the switch where the face won't be damaged, and I put this down on a surface, and standing over it so I could get some leverage, I continuously swiped it down this part of the file, a rough part of the file, and that allowed me to remove a little bit of material. You can see sort of the scrapes out there, and then I went back with my X-Acto knife and removed a little of the material near the front, because you can imagine once it's in position, once I push it in there far enough, we want a sort of a groove or something that it's going to feel comfortable sitting in and not want to pop back out. So let's see if we can get that in there. All right. So I'd say that's in there pretty reasonably. And what we'll do then is I'll just cut another piece of this aluminum flashing that I made this portion of the back with and put it across right here. And then that'll close up that little hole there, and we'll be all set. And the way I'm going to make that little piece of flashing is I've just been using this piece of roofing flashing that I had laying around the house. And, we just want a rectangular piece. It'll be down there, so I'm just going to cut it with these tin snips. And it just happens that I notice when I'm cutting with tin snips, the edges aren't particularly sharp, so that's an added bonus. And that'll just I'll just go down there, and I'll use some epoxy, I think, to put that there, rather than remaking a whole piece here. I guess I also have the option of putting it on the inside. That might be interesting. Turn it around. Maybe I'll do that. I'll make a piece that I can glue on the inside. It'll look a little bit more finished than from the outside. So now I'm just going to put everything back together. Say the drive's all up and running well. I put it through its paces, running it for a number of hours. For instance, we can load the Commodore Model 1541 test demo disk and the check disk program on it. And remove that. Let's test out a disk. There we go. Well, I won't keep you here for the whole test. It runs a long time. So I'm really happy that the drive is in working order, and I've got the DC power input. The project isn't a complete success yet, because what I haven't been able to do is get this power supply, the dual power supply for the 64 and the 1541-2 to power my 64 and my 1541. What I'm finding is that the 1541 draws more power on 12 volts than this thing wants to supply, especially in combination with the 64. So there's too much detail to go into in this video. That's a standalone project, but right now what I'm doing is I'm not using the on the Keelog, I'm not using the 64 power supply. I'm just using the dual PSU to power the 1541. And my experience with it in this project is that this particular power supply, the dual PSU meant to power the 64 and the 1541-2, provides enough power to power just the 1541. And it's because the 1541 needs something like 2/3 of an amp on 12 volts to power the motor and stuff. So that's an ongoing effort. What I'm doing now is I'm powering the 1541 with this Keelog supply, and I'm powering my 64 with my good old trusty original 64 supply. But I'll get another one, and we'll do another video, and I'll show you what I find and do some evaluations, proper evaluations of what kind of current you can actually draw with these replacement PSUs. Please let me know in the comments, or like if you think it's a neat idea, and let me know if you have any thoughts about the project. Thanks. That's it for now.